My name is Victor Kwan. I'm the head of developer community for Sourced. And today I'm really happy to be the host for our first online meetup. We have our speaker and VP of Developer Relations, Francis Campoy. Please take it away.
Yep. Okay, so I hope you're hearing me now. Maybe you can do like if anyone is listening to us could say something on the chat just to make sure that we're all fine. Perfect. Okay. Oh, that's gonna be annoying really quick. And I cannot even control it. Okay, that's cool. So, yeah, thanks so much everybody for coming today. The goal of today's presentation is to show you a little bit all of the things we've been working around ML code and code as data. I will do a little bit of a demo initially explaining what we are working on, what are those fields, and then we'll go into a live demo of the engine, which is our solution for the code as data needs. And then also I'll show a little bit on the lookout part, which is code review, assisted code review, which is very, very much alpha. So we'll be seeing a little bit how it works, what's the whole idea. And I'll show you a little bit of the places where we are already using it, we're dogfooding it. And then I'll show you how you can run it yourself if you're interested in that. And also at the end, we'll have Q&A. But if you have questions in the meanwhile, feel free to send messages to the chat. I might not be able to see them, but I'll make sure that Victor, who's sitting next to me, can have a look and ask me anything. So if you have any issues or questions, feel free to go for them on the chat. Cool. So as Victor said, I'm Francis Campoy, and I'm the VP of Developer Relations here at Sourced. And normally I do not give my email around, but there's a petit comité, so why not? If you have any issues, feel free to send me emails or tweets or even issues on GitHub if you feel like it. But today we're going to be talking about first what is Sourced. I'm going to explain a little bit what it is. Then what is code as data, the field itself and the solution that we propose, which is the Sourced engine. And then what is ML code, the research field, and the solution we propose, which is Sourced lookout. And then we'll have Q&A, but again, feel free to interrupt at any time. Okay, so what is Sourced? And first thing, how is it pronounced? It's pronounced Sourced, not Sourcedy. I know that many people get confused about that. Me too at the beginning, so don't worry about that. We pronounce it like one word. And, oh, there you go. So Sourced comes from this realization, right? Like the realization that we have a lot of source code out there. There's this very well-known phrase, software is in the world. And I think that software is not only in the world, but actually the amount of software we have keeps on growing at amazing speed. This is a little example of the kind of software we used to have a long time ago when I was born. So this is the first version of Adobe Photoshop. Well, the first 1.0.7, which is pretty early on. There were still no colors. This was already 128,000 lines of code. If you continue into Windows NT 3.10, this is 4 to 5 million lines of code already. Think about your normal code base, how many lines of code you actually have, and how do they compare to these things? And when you think about the lines of code, I want you to think about the lines of code, not the ones that you wrote, but also all of the ones you depend on, all of the dependencies, third-party libraries, and things like this that you might not have total control over. Apache OpenOffice has 9 million lines of code. Our dear Chrome that just updated to version 69 right before this presentation has 18 million lines of code. And Windows Vista, which we all recognize, no need for a name, has 45 million lines of code. And this is not even that much. If you consider things like, for instance, this Ford car, this has 150 million lines of code, which if you're a little bit like me, which is someone that loves technology, but also his own life, you might be a little bit scared of this. 100 million lines of code is a crazy amount of code. And having the trust of letting it drive a car is, it's a challenge. You need to have a lot of control, quality control around all of your processes to make sure that those 150 million lines of code are actually safe. Typical example of the largest code base is Google with 1 billion lines of code. But actually, even more interesting, how many lines of code are there on GitHub? Well, it depends who you ask. So what we did was we used BigQuery. BigQuery has a public data set with a bunch of different GitHub repositories. And we'll talk a little bit more about this and how we're using this at source. And if you count all of the lines, it says 55 billion lines of code. So that's around 55 Googles. Now, the problem is that this data set is far from being complete. So it's probably a couple orders of magnitude larger than this, the actual number of source code we have. And still, we're using pretty old style tools. I'm sure that most of you are using an IDE. Maybe some of you use Vim or Emacs as editors. And these tools are great, but the problem is that while they might have been useful to build some initial tooling, some initial projects, like for instance, managing 128,000 lines of code that the first version of Photoshop had, seems pretty challenging, but still doable. But when you're going into code bases that have millions, maybe billions of lines of code, it is just very hard. You're gonna need better tooling, right? It's similar to in architecture. With some basic tooling, you might be able to build that very cute doghouse. But if you want to make it scale and build something like this terminal, the transit terminal in New York, you're going to need better tooling. Otherwise, it will just not work, or it will eventually just break down. So you need to be careful with these things and try to see how those tools can evolve. So given that, we decided that since there's so much code, that code should be used, right? Like many people see their code as almost a side effect of what they're building, while at Source we believe that the source code is not only one of the main products you have, but also is one of the main sources of information that can inform you on how your company and your engineering teams are actually doing and performing. So when you think about code as data, the first thing you need to think is about the fact that, yeah, we probably have around the world trillions of lines of code, right? So what we need to do is just do data mining on that. And well, is that enough? Well, as I was saying before, there's a BigQuery data set, and this BigQuery data set contains a lot of code. And I wrote this blog post a long time before I joined Source, even back when I was working at Google. That shows a little bit how you can analyze Go code by using BigQuery. BigQuery is a SQL interface with a powerful engine behind, but it's no more than SQL, really, right? And you can do interesting things like count out of all of the names for Go files, which ones are the most common, right? The most common ones. And you can see that, for instance, doc.go is the most common package name, file name for Go. And this is great, but is this enough? Well, what if I told you that now I want to analyze the names of the functions defined in those files? So, well, to start with, it really depends on what language you're using, right? Like in Go is func main, but in Rust is fun main, and in JavaScript is function, and then in Java is public static void main, whatever, right? So every single language is going to have different issues. So you're going to need to first know what language you're handling, then also be able to parse that and extract the pieces of information that you care about. So in this case, it would be for all of those examples on top, it would be the word main, that's the name of the function, but it appears represented as completely different ways depending on the language you're using. And this is why we have this project. It's called Babblefish. And I will not get too much into the details of Babblefish. I'm just going to do a very quick demo. Let's see if everything works. We have a dashboard here. This dashboard is a pretty simple example of what you can do with Babblefish. Here on the left side, you see some source code. And on the right side, you see the result of parsing, which is what we call the UAST. So UAST stands for Universal Abstract Syntax Tree. The important thing is it's universal the same way JSON or XML are universal. This is just simply a format, a common format that allows us to, once we've parsed the program, extract pieces in a language agnostic way, right? So for instance, let's say we have here all of this code, and you can see that this part here, for instance, has been parsed as a method declaration that contains some children, and you can see the children here. So you can see that there's a token public for visibility. There's a primitive type, which is void. There's a simple name. And now imagine that you want to extract all of the simple names from this program. Well, we use XPath that allows us to do things like this. Extract simple name, and now all of the simple names we have are, for instance, the token is Java, that's a simple name, IO, and if you go a little bit lower, you can see print writer or PW, all of these things are names, right? So now, if you wanted to do the same thing with Go, well, we just need some Go code and the Go parser. We run it, and we can do, again, simple name. And actually, that doesn't work because we just changed the the way this works. So now it would be actually ident in this driver. We don't have exactly the same versions on the dashboard. That's why. But the whole idea is that those names, the roles, expression, identifier, those are language agnostic, and they allow you to extract the piece of information you care about. And this is Bubblefish. Is there any questions regarding Bubblefish for now? All right, cool. So let's continue. All right, so now we have Bubblefish that allows us to extract all of the information we want, because the other option is, of course, using regular expressions. And it is hard. I tried to do it myself with BigQuery, and it kind of works, but it works for one language, right? If you try to go into multi-languages, regular expressions will never be enough. That's why we have things like Bubblefish. Okay, so for Go as data, then we have data mining and language classification, parsing, and token extraction. Is this enough? Well, first thing is we actually need to expose this, and I'll actually get to that slide in a second. No, actually, yeah, I'll continue here. So the language classification is actually not done directly with Bubblefish. It's actually a different project, which is also open source. And it is exposed for us as a simple function. So if you have SQL, you can see here, there's this language function that, given the path, so the file name and the content, it returns a language. And this is something that you can do very easily inside of the engine. And we'll see a live demo of this later. But the whole idea is that this different feature that is not part of SQL, we just expose it as a custom function on SQL, which is pretty familiar to anyone that has used it before. Then we also have this other function, sorry about that, UAST, that given the content of the file and its language, that could be Go or Java or whatever, and some filter in the shape of an XPath expression, as we did in Bubblefish, will return the results of that parsing. So in this case, for instance, what we're doing here is we're extracting, so we're parsing this content in the file that we detect, and then we're extracting all of the function declarations. So that is the role function and role declaration. That's an XPath expression. And then we're actually counting the array length. So we're able to extract how many lines, how many functions have been declared per file. In this case, Go, because we're limiting it here, but you could do exactly the same for any other language. Okay, so now we have code as data, we have data mining, language classification, parsing, and token extraction. Is that enough? Well, we actually care about evolution, right? Like our code, it's not only how our code looks like now, but also we want to understand how it looked like before so we can predict what it will look like later, right? And in order to do that, the BigQuery dataset that I was talking about is not enough because it only contains the latest version of the head, the master, well, the default branch, just the latest commit, right? And this is kind of complicated, but we can do that. We actually store all of the revisions that are available for a given repository, right? So we have a Git repository. We keep it completely, not just the latest version, but we're able to analyze all of them. This means that all of a sudden we have a combinatorial explosion, and we have way more files and references than before. But it is worth it because we need it. And what's left? Well, now we are actually managing Git because we have many revisions and things like that. And actually Git is a very simple model once you understand it. But it is definitely not easy to understand, right? In order to get to the content of a file, you may need to start from a head, which points to a branch, which points to a commit, which points to a set of trees, which eventually point to blobs, right? This is kind of complicated. And by the way, this is a great talk by Jeff Kunkel, Understanding Git. I definitely recommend it watching if you're more curious about how things actually work. But this leads very often to the problem where people see Git as something that is almost magic. We just understand Git pull, Git push, Git commit. And if everything fails, as this XKCD says, just delete the repo, create a new one, and just copy paste, right? These things I've done, right? Like this is something that we see all the time. And we don't want to force analysts or anyone that is interested in understanding code to have to understand these extra concepts. So that's why we actually have a Git to SQL mapping. And I will show that in a minute. The whole idea is that you do not need to understand Git to be able to extract this information. You just need to understand the relationship across a series of tables that we provide. And last but definitely not least is open source and is Apache 2. So I definitely invite all of you to go check it out. And now for the demo time. Okay, so for this demo, what I'm going to do is, can you see that correctly? Cool. Yeah, you cannot see the top of the screen, can you?
Yeah, we can.
Oh, okay, that's it. Cool. So in order to install the source engine, you can download a single binary, which is available on GitHub. And this is the binary. And it has a bunch of different verbs. It's a very, very small Go binary. And it only depends on having Docker installed. That's everything you need. It's this binary and Docker. And no matter what platform, whether it's Linux, Mac, or Windows, this will work. So now I can do things like source SQL show tables. And now you can see that I get the tables that are exposed on Git base. Now, these tables are the ones that correspond to the Git concept. So for instance, you have repositories, you have remotes, you have references, and all of these things. So let's try to analyze it a little bit. So I'm going to enter source SQL in the interactive mode and see what repositories I'm working with today. I'm working just with one repository, which is all of the Go source code. So I just clone github.com/go/go, just as an example of the things you can do. So now let's say, as I was saying before, there's many references, right? There's one repository. How many references? Well, actually, many of them. But since we know SQL, we can count them. So there's 251 of them. And now, something that might not be a great idea, but how many files do we have? And now, think about what is going on in here. How many files do we have is not only how many files we have in the current head branch in the current commit, but also all of the ones that have ever existed, right? So this is actually going to be really, really big. And I wanted to show this to give you a little bit of the idea of the issues that you might face once you're working with the engine. One of them is the fact that there's actually a huge data set behind it, right? It is hard to see because it kind of hides. We don't really see it when we just go into a folder. But actually, that .git folder is full of many, many things. And navigating them is not always the most obvious thing. So I'm actually going to kill this. Instead, we're going to go into a better way of using this, which I like, which is Okay, good, configure. So you can do sourced web SQL. And now what we're going to do is we are going to open a SQL client as a web dashboard. And this is something that I really like. So it's going to be downloading a Docker image. So you will see these kind of messages whenever you're using something for the first time. And I can hear my computer warming up. I don't know if that's Zoom or Docker or what. Let's see. Oh wait, sometimes it opens it with a warning. Kind of gets confused with the full screen. Okay, so now I just open that localhost 8080. And now you can see that this, what we call the Git-based playground, which you can imagine as an engine playground, really. The engine is just a conglomerate of a bunch of different pieces of projects that we've built over time. And the engine is really the way to access all of them in the easiest way. So now you can do the same thing, right? You can do select star from repositories, and we should get the same result. Should just say there's only one repository. Now, the interesting thing is that you can do pretty advanced things, like for instance, give me all of the files that are called main.go. And not only that, but actually, as you can see here, we're also detecting the content, the language, and we're using that language to parse the UAST. So now when I come here, you can see a bunch of different Go files, which are all Go, which, you know, it's pretty obvious. But if you had something like .m, is M Objective-C or MATLAB or any other language? We actually look also inside of the content, and we use machine learning to decide what programming language it is. And it's very fast. It's similar to other projects like Linguist, but it's much faster. So now you can go and see the code inside. You can see that we have some Go code, and you can see around. But also, you can see the UAST. So now you can see the abstract syntax tree that we parsed from that code. So now you could do something like, let's see, something interesting. The package name. So we can do, will that work? Yes. So we can see all of the identifiers. And I'm going to try something which might not work, because I never know exactly identifier expression. Nope, didn't work. That's not how it works. I'm still learning that syntax. We just changed it recently. So anyway, you're able to extract this piece of information. You can do this from here, or you can also extract them directly here. You could actually do something like ident. And this would then return all of the identifiers. Then you should merge them together or count them or something like that. But this, a little bit of a demo of the kind of things you can do. You can also do a little bit more interesting things. Like for instance, last commit for each repository, which is going to be pretty fast because there's only one repository, but you can see which one is the latest commit that happened, right? Imagine that you have a lot of different repositories, and you want to manage which, like, how often do they get updated? This is a very easy thing to write with just the engine like this. Something that I will not show, but I think it's worth having a look at, is the fact that you can also use this. Actually, let's do it real quick. This is just a SQL database, right? A SQL server running. Now, this means that I can connect to it with MySQL. Simple as that. This is a standard SQL database. So you can do all of the things that I was doing directly through the engine. You can do it from any other SQL client, be it this one, the MySQL client that you can install on Mac with Brew, but also if you want to connect to it. For instance, I really like using Jupyter or IPython. Some of you might know it by that previous name, as a way to connect to it and be able to print nice graphs directly from there. You can also connect it to Tableau or any other dashboard tooling that will allow you to extract information you care from your Git repositories as if it was just a simple database. Okay, any questions about this part so far? Because now we're going to move into the ML code section. No? Okay, cool. Cool, so let's talk a little bit about ML code. So far, everything we've seen is how we extract information from code bases. And this has a huge value, a huge intrinsic value, because many people have to deal with these large code bases and you need to maintain them. But on top of that, once you're able to extract these large code sets or code bases, then you're able to use them to train neural networks and all of a sudden do machine learning on source code. And this is something that we coined ourselves, the ML on code thing. It's not something completely new. There's a lot of research going around. There's people from Microsoft and many universities that have been working on something similar to this. But we do believe we're the first company to actually apply this. So the first challenge of machine learning on source code is data sets, right? We have GitHub archive, which is something quite common. But the problem is the GitHub archive does not include the code itself, which means that very often you need to iterate over all of the repositories that appear in GitHub archive and then clone them, which has a lot of different issues. So we did that ourselves, and the data set we created is called public Git archive, and you can check it out on pga.source.tech. It is around 4 terabytes of code, and it's what we use whenever we want to analyze anything, really. Like if we want to train a model, this is our default go-to data set. Then all of these different things that I show here, different tooling, different needs of how to retrieve that data, all of these covered by the engine. So if you want to know more, feel free to ask questions, but otherwise, all of these things are completely managed by the code as data section. So that is the engine, which we released recently as beta. Okay, so now that we have all of that code as data part done and we have all of the code, how do we analyze it? And it really depends, right? Like, there's many ways of understanding what source code is. One of them is saying, well, this is simply a bunch of bytes, which is accurate, right? Like when we're storing a file, you're storing the bytes of the file. And you can train things based on these bytes, just the bytes. It's not the perfect solution because there's a lot of abstractions that do not appear or are not represented easily, so a model can learn them, but it is not impossible. We can also think about, since we're talking about parsing, we can talk about every single token, right? So we have package is a token with the text package, main is an identifier with the text main, etc. And then with this, you're basically given a slightly higher level of abstraction. But with this, you're still far from giving all of the information we know from the source code to the neural network that you're trying to train. And then, this one here is this one is closer to what we normally work on when we're talking about the EOSTs, right? Like we're talking about abstract syntax trees, we're talking about trees. Trees are kind of graph, cyclic graphs, right? So this is something that is way more useful because all of a sudden you're representing the program in a place where hierarchical representation is easy. You can actually understand what is a function, what is a type, all of these things starts to appear in a much more obvious way than when we're representing it as tokens, let alone say bytes, right? But this is not even the final form, right? We actually have more information. We have a lot of different algorithms that can extract extra information. So one of them, for instance, is finding out what is the control graph. So we're able to say, you know, given this code, these are the jumps that we can detect. And then we're going to be able to express these things and show them to the neural network that might learn more stuff. There's other things like, for instance,
So Muhammad is asking if you can go through that again.
Through what?
What about that piece you just listed?
This one. So yeah, basically, let me start from here. Basically, source code can be seen in 4 different ways. One is a sequence of bytes or characters. You can see the sequence of tokens. You can also see it as a tree, an abstract syntax tree, right? And this is why we have the universal abstract syntax trees. It's so we can learn from abstract syntax trees in a universal language agnostic way. But this is not the last way, the last form we can represent things, because we have more information, right? So for instance, once you start taking into account loops and conditionals and how we can jump from function to function, you can create what is called a control flow graph. And this is now a graph because there's, by default, there are cycles in here. You can also think about once you start pointing from usage to definition, like you say, well, using this variable A here, and that is where it was defined up there. Now you have extra arrows that are going to create graphs. So now all of a sudden you have, again, graphs rather than trees. So now you have this, you're going to also have to learn from graphs, which is a much more interesting thing. It's pretty complicated, but it's definitely worth it because the results are actually very impressive. And then we need to learn from this. And this is the part where I will not get too much into detail because we don't, like, I do not want you to think too much about all of the things that are going on in the back, right? Like we have a lot of different algorithms and we have a very large machine learning team working on these kind of problems. So you don't have to. We will show how this applies to you in a minute. But anyway, we use neural networks everywhere. And neural networks, basically you give them an input and then it will generate some random output. And then you keep on insisting, no, this is not how you do it until it learns, right? This, from a statistical or mathematical point of view, a really bad definition, but I think that it shows enough what it does, right? It just like learns by the power of repetition. I like to say that neural networks are kind of like puppies. You just need to educate them and repeat the same message over and over and over, and eventually they'll get it. So the typical example for machine learning with neural networks is basically the hello world of machine learning is MNIST, which is a data set containing images of handwritten pixels. So as you can see here on the left side, you have 8. That is a 28 by 28 pixels, which is 784 pixels. So we're just using that as the input. And then we have some extra layer, and then we have the prediction layer. And that prediction or output layer contains 10 different digits. So it goes from 0 to 9. And the one that approximates 1 is the one that we think it is, right? So in this case, it says, indeed, this looks like an 8, which is correct. If it was not correct, then we would actually apply what we call gradient descent and backpropagation to retrain this until it learns. So again, here you need lots of data, like really a large amount of data. So how can we use this for our problem? Well, predicting the next token is something that we see pretty often, right? Like for instance, here you see for I equals 0, I is less than 10, what's next, right? So I mean, it could be plus plus, it could be minus minus, it could be an equal. There's, from a syntax point of view, there's many options that are possible here. But once we're training the neural network with the source code that we actually see, we know that the highest probability will be plus plus because there's a loop going up, right? And this seems like an easy thing, but it is actually very useful for something that I will show in a minute, which is not really predicting, but rather detecting anomalies. When you want to work over not a fixed sequence, like in the previous example we had, I think it was like nine tokens and you need to predict the next one. What if I want you to predict n next tokens? You cannot do that with traditional neural networks, and this is when we're going to be using recurrent neural networks. And this is where things start to get interesting, because this is the kind of technique that you're going to be applying for natural language processing, which are the same techniques that we are applying also at source for machine learning and source code. You can also think about other techniques that we apply, like embeddings, which is a very well-known, and there's a very well-known embedding called word-to-vec for NLP, natural language processing. We have ID2vec, which rather than embedding words, it embeds code identifiers. There's a blog post that Vadim, the leader of the machine learning team, wrote recently. You can find it on blog.source.tech. So once you have this, you can generate some code. And I did this. Before the neural network was trained, this is what it thinks the code looks like, which is pretty bad. Later on, it starts to look more like Go to the point that it writes that line of code. If errors, no nil, return error. I'm sure that if you've written any Go or if you read any Go, you've seen that line before. So Gophers are happy. And it keeps on evolving, right? And it keeps on improving, but it's actually far from being good enough. The biggest problem is that when you're doing natural language processing, when you have something that is slightly weird, slightly wrong, you can consider it as being artistic, right? It's natural language, it's very flexible. But here we're talking about source code. Source code is anything but flexible, which means that if you have something that is not exactly correct, it will just simply not compile, right? So even though we are applying similar techniques, the way we need to apply them is different because of the constraints of the business problem. There's other two research pieces that I wanted to mention because they're very important and it's something that we're working on applying also. So one of them is learning to represent programs with graphs. That the interesting part is that they present this task called the var misuse. And the var misuse task is basically, I give you a program, I remove one of the identifiers, and you need to guess which one is missing, right? So in this, on the code on the right side, for instance, I'm opening a file, and before closing it, I opening another file, and before closing it. Var misuse basically will be able to predict that the question marks should be replaced with 2, the identifier TO, right? This seems like an obvious thing, but it's incredibly useful. And we'll see why this is useful, not as the prediction, but as the detection of anomalies in a minute. And finally, the other one that I really like, it's code2vec that allows us to do things like, as I was saying, learning from graphs and predicting the name of a function. This is also quite interesting. You can, for instance, see in these examples how the one on the left, since it returns a Boolean, it iterates over a thing, and if it finds it, returns a Boolean true, then it says that that's contains. It should call contains or matches, maybe. The second one, it actually returns the element that it found or a default value. This one is get. Well, if what you return is not a Boolean or the element, but just the index where you found it, that is index of, right? All of these things have been trained over a large Java code bases, and this is the result we're able to do. We are trying to apply these things in a language agnostic way to as many languages as possible, so we can use these tools for any project. And if you want to learn more about this research part of things, I definitely recommend looking at this repository, the awesome machine learning on source code with this awesome logo created by our in-house designer, which I really like. And this contains a huge amount of papers tagged from good for beginners to advanced and separated by categories. So you're gonna have NLP and mining repositories and all of these things separated. So it's definitely worth looking at it to see basically where we're going, but this is definitely the future. This is the research side of things. But to finish is, okay, so this is cool and all, but how do we use it, right? Like, can we build anything useful out of this? And as I was saying, the whole point here is rather than predicting things, I think it's interesting to see that very often we are also given, we're not only given the code that we need to analyze, but also the result that we got, right? So for instance, predict, given them these 10 tokens, predict the next one. Well, if you have a file, that 11th token is also there, right? So instead of trying to predict which one is the next one, what we can do is predict how expected that answer we got was. So imagine that you have something such an attention model for code reviews, which is something that I've been working on, and I actually wrote a little demo, and it works, which is very exciting. And I actually made it work based on characters, which is the simplest and most basic way of doing it, and the accuracy was actually pretty decent. So you can imagine that if you go up on the scale of the level of abstractions, if you go into tokens or abstraction text trees, the result will just get better. So imagine that you're given this very large code base, this very large pull request, and we're able to tell you that out of all of this code, which all looks quite similar, that actually there's 2 areas of code that are actually interesting. And by interesting, it doesn't mean they're wrong. It just means that they require more attention because they're not as expected as the rest, right? And this is, for me, something incredibly useful because basically what it's telling me is that the rest of the code not only looks normal, but actually is normal, right? There's not a single misused less than instead of larger than and things like this, because that would actually also show. So you're just showing, well, these pieces, we don't really know, have a look at them first. And these are already very useful. Regarding the var misuse problem, we're also working on being able to use that to detect the issues on existing code bases. So for instance, here you will be able to see if you write this, that there was a copy-paste mistake, obviously, because we're closing the same file from twice, but we're never closing 2. So this is something that var misuse problem is able to detect. Similarly, we're able to predict function names, which seems less of a useful thing, except that actually if a function is not named correctly, that's a huge problem in the future for maintenance. So detecting these kind of problems as early as possible is actually very important. And once you put all of these things together, that's when you get to what we call the assisted code review, which is what we're putting all together into Source Lookout. Now, Source Lookout is the open source effort that is a platform. So let me see. Let's go to, ooh, my Chrome is suffering. Where did the bar go? Where? Excuse me? No, but where do I type things? The new version of Chrome doesn't have a URL bar. That's sad. Okay, so I guess I can type it here. Yeah. My keyword is not working. Let's wait a second. It is actually not working.
And you only type it.
I don't know. It's working. I just like. Lookout. Many demos have broken, but the fact that my keyboard would stop working, that's new. So Lookout is our assisted code review solution. And I'd say that the most important piece of information to remember is that this is the future. It is alpha, and we are definitely looking for people that will use it and also give us feedback on it. We're looking for alpha users and people we can collaborate on in order to add new features to it. Now, Lookout itself is no more than a platform. So the whole idea is that in this platform, you have a set of analyzers. And there's an SDK that you can use to develop those analyzers. An analyzer is something that receives the current state of a code base, analyzes it, and gives comments on it. And those comments will appear directly as comments on a pull request. And the whole idea is that we are doing all the language detection, all the parsing, all the obvious things that every single analyzer needs to do anyway. So you can just concentrate on the piece of information that is actually useful. Now, we are working on building analyzers that are machine learning powered, but not only, right? One of the ones we have is actually our dummy dummy analyzer. And the dummy analyzer is pretty straightforward, is total of 170 lines of code. So you can have an idea of what it actually does, but it checks for things like, oh, the max line length should be 120. And if not, I'm gonna add a new comment saying that, oh, this was not good enough. Now, the cool thing is that then once you have all of these analyzers written, you can configure it on any repository. Is .lookout.yaml. that tells me which analyzers they should be running. And in here, for instance, it's running dummy, but also it's running Go MetaLint analyzer, which is something that analyzes many, many different things regarding Go code. The interesting thing is that none of these are actually powered by machine learning, but we've been working on many demos that allows us to use machine learning directly here. So just to show you a little bit of how this looks like, this pull request sent by one of our engineers, Carlos, into this repository, the lookup repository. And since we are already using the reviewer, the lookup bot, we are doing the dog fooding and making sure that our engineers are happy with it before your engineers get to use it. You will see that one of the reviewers is the lookup bot, which you might recognize from Futurama, which I'm not sure from a point of view of copyright how good that is. But you know, it's alpha, so we'll change it before we get to. But anyway, so the interesting thing is that he sent this pull request, a bunch of different comments, and directly lookup bot started commenting on things, saying, well, this line of code is actually way too long. It's 133 characters. This one too, 153, 134. Okay, something a little bit more interesting. Duplicate of common server test or analyzer test ago. So we're actually also detecting when we are copy-pasting full fragments of code across files. And basically pointing out to the fact that rather than having this copy-pasted in a bunch of different places, it'd be a good idea to define a function that we can reuse, right? Like do not repeat yourself is something that we can do quite easily because we're able to detect duplicate code thanks to actually machine learning. Let's see, so this also has duplicated. Go imports, for instance, the result, this file has not been, the import statements are not correctly in order, or some of them are missing or extras. So we're saying you need to run go imports, etc. And the whole idea is that this is only two different, these two different analyzers. We have dummy, which is the one complaining about the length of lines of code. We have Go MetaLint analyzer, which is a very straightforward analyzer that just runs that tool, Go MetaLint. But you can add extra analyzers in a quite straightforward way. And this is what we're looking for people to do now. To either create analyzers that solve some of their problems and see how they integrate with the whole developer experience of sending a pull request. And also on the other side, we want to make sure that you're also able to let us know the kind of things that you're dreaming of, right? If you have some ideas of like, well, you know, like this is something that I need to remind my developers every day when they send a PR, this kind of comments appears very often. Well, maybe we can automate that. And if we're able to automate it, means that you're actually giving extra time back, not only to the developers that are reviewing that code, because now it's automated, they don't need to complain about those things anymore, but also you're giving time back to the engineers that are writing that code initially, because those comments will be sent back to the developer immediately. The time for the review goes from hours to seconds, maybe minutes. And I think that that is the most important thing is we're trying to power a whole generation of developers to be more effective thanks to machine learning. We're not trying to replace them. What we're trying to do is just to empower them with better tools, as I said at the beginning. And I think that I'm gonna finish it here just so we have time to do some Q&A. But yeah, if you wanna learn more, I definitely recommend checking out our source.tech website, which we did not that long ago. We're working on automated style guide enforcing. This is a very interesting one that is working already for JavaScript. It's an analyzer that learns the formatting rules that you've applied to your source code, to your whole repository, and then applies them to the new pull requests. So basically, it's a self-configurable linter for JavaScript. We're also working on back prediction. We do think that once you have all of the information about how source code evolves, you can predict what the next change will be, even what the next defect will be. And we're working on this. Also, there's things like education and code generation and natural analysis that are more far-fetched. I think this is more the future, really. but it's something that we keep in mind as we are working on Lookout and all of our ML code tools. And that's it. We have still like 10 minutes for Q&A, so I don't know if you have any other questions around.
Can you elaborate a little more on your bug prediction use case?
Yeah, so if I'm able to use Google, I swear Google is not working for me. That's so sad. How do you break this? So let me find, there's a paper. Yeah, so this is one of the examples, deep tree-based model for software defect prediction. There's actually all of this section, program repair and bug detection, that definitely recommend looking at. Basically, the whole idea is we're able to see the evolution of source code and even tie it down to things like a commit message contains fixes or things like this. Like it actually mentions that there's a fix for something. We're able to learn from those and try to see what is the tendency of source code to change. And we can see things like, well, you know, this pattern tends to change to this other one. It doesn't necessarily mean that the first one is actually wrong, but if there's a reason for it to migrate to the second form, it is because either it's more effective or it is more correct, more robust, or maybe there's a new version of source of a library that we're migrating to, right? In any of the cases, this is the kind of thing that once you're trying to do maintenance work on a code base, having this information can point you to where you should be spending that effort, where you should be putting an engineer to make sure that that code is correct, and that it needs more maintenance. And you can do it by two ways. One is using code as data and trying to figure out how often things change. And if something is changing all the time, it's either in active development or it's a very complicated code base that requires a lot of maintenance, right? So you can use those as an indication of where to go, but also you can use ML code in every single one of these papers here to try to write, which is something we're trying to do too, but trying to run an analyzer that you can then apply your pull requests.
Another question we have here, what about detecting suboptimal code? Like the function performance is linear and it could be the guideline.
That is super interesting because it's actually one of the papers that I was reading recently from Miltios Alamanis. They wrote a bubble sort detector, which is pretty amazing because the whole idea is that, I mean, if you're a programmer, you might know that bubble sort is a really bad program, really bad way of sorting things in general. It's, if I'm not mistaken, is squared, like the performance is squared by maybe exponential. I do not remember now. I'm ashamed of this. But anyway, it's a bad thing to do. They were able to train an analyzer to detect specifically this kind of algorithm, no matter what the context was. So even if they were sorting things that were completely different, they were able to understand, given the control flow graph, what is the algorithm that you're actually running, and then basically warn about the fact that this is not the best solution. These are things that are very specific. For instance, in this case, there's like, oh, we have this specific version of this specific algorithm that we want to detect as something being negative, and you can do it. There's also another effort that I find very interesting, which is a little bit more on the future of ML and code, where the inputs are not only the code base itself, but also things that we're detecting from production. So there's this paper there's this work, actually, if I'm not mistaken, it's his doctoral work, his PhD of researcher at MIT, Jorgen Sito. He worked on a project where he's able to predict the performance of a piece of code given the performance of all of the other pieces of code running on production. And then in that case, you can see things like, well, by adding this for loop here, you're actually multiplying the performance times n, right? And these things, you can warn them in a quite a straightforward way. that is not necessarily what we're working on now, because we're concentrating on things where all of the input is inside of the Git repository, but it's something that we definitely consider for the future and different tasks that we could add once we start merging things with other inputs, like logging and observability and all of these things.
Another question from Manuel. Lookout is super interesting. I'm wondering what are the next steps? Is Source planning to have a Lookout offering with a bunch of analyzers to choose from?
Yes, that was an easy answer. So yeah, we're definitely working on having a Lookout application, GitHub application that you can simply add to your repository. We are still playing and trying to understand what is the best way for us to get feedback from your interaction with the application. That's why it's alpha. Many things might change in the future. But the whole idea is that we want something that will minimize the time to merge for any PR, plus will minimize the effects that go through without being detected, right? There's many analyzers that we're working on. The whole idea is that what we want to do is we have a huge set of very different analyzers. Some of them work only depending on the language you're writing on, which is something we can do because we have the language classification. And then on top of that, we also allow you to, with that .lookup.yaml file, configure if you want to use only a subset of those, but also if you want to use something that you've developed yourself. Actually, when you are doing that analysis, what you need to do is you need to give a webhook. And once you give that webhook, we can do the analysis over gRPC, over the network. Which means that if you're running this on GitHub, then GitHub will send something to our application that will send something to your analyzer, which is totally fine, but things are going on in the public. If you're interested in having these analyzers also running locally, that is also something we're working on. We're working on having this integrated with GitHub Enterprise, but also you can run it on Docker anywhere. So the whole idea is the whole platform has been developed so it is easy to integrate with other things, like we also considering integrating with GitLab, maybe Bitbucket, and all of these different platforms. So you can use the analyzers, run them only once and run them anywhere.
Another question from Leonardo. This might be too vague, but do you think advances in this area would lead us to better measure the code quality? Do you have any pointers to learn more about this direction?
Yeah, that's a great question. I think that especially code as data, there's a really good book, Your Code Base as a Crime Scene. I've looked for that many times, I guess. The book is right here, The Pragmatic Bookshelf. This book talks about how you can learn a lot about a code base by looking at the way it evolves, how changes are correlated across different files and things like this. This is something incredibly useful, and I'm actually going over the book again to try to understand how the engine could be used to extract the information that he mentions is useful. So that is something very exciting. I think that even more exciting is the fact that by using machine learning, we can actually not only see what's happened in the past, but also predict the future, right? So if you have a large code base, and then you're able to predict some patterns, you might be able to find things like correlation across issues in two different data repositories, which is something that I've already seen before, where it turns out that there's a dependency because you need to run some code generation based on the code on a different repository, and people forget to do that, so you get these issues constantly, right? And once you're able to predict these things, the hard part is going to be understanding why those are issues, but we can point to areas that are problematic. In the future, what we want to do is basically have kind of like architecture analyzer or code reviewer analyzer, like all of these different roles of people that their job is to read your code base or your architecture diagrams and understand where the bottleneck could be. If we could use machine learning to detect these things, that'd be also very powerful. And that's something that we definitely consider doing in the future.
All right, last question. Are there plans to provide Lookout as a static analysis tool so that my coworkers don't get to see the bug?
So it is definitely an option. right now we're concentrating on pull request level because mostly some of these analyzers might take a long time. Think about the fact that you're running machine learning, you may be doing feature extraction that might be costly. So that's why we don't have this as something that you run directly on your editor on save. Otherwise, it would take more than half a second, and then it's kind of useless, right? So that's why we're concentrating on having it work directly on the pull request. That said, there's two things we're doing. One is you can have a fake, kind of like a fake pull request, a fake server where you're running that analyzer on the code that you have on your machine without ever leaving your computer. This is something that you can do today. And the other side is we're considering trying to figure out, so the first step when you send that PR, it's just the bot analyzing your PR, but only you can see it. And then as soon as you fix those things, the comments disappear. So then now you're able to send your PR without the bot shaming, but the person that receives your PR having the impression that you're an amazing programmer, even though there was a lot of mistakes that were removed in the way before they get the access, they get the chance to see your code. So we're working on both sides. It is important to take into account that, yeah, if you run it locally, don't do it on save, because some analyzers like the Go middle inter that I was showing, that can take sometimes up to 2-3 seconds. If you do it on save every time, after a minute, I'll promise you that you'll stop.
Great. So I think we're out of time. Just thanks everyone for joining. So this is the first of a series. We'll be back with the next online meetup. We'll follow up with an email sending the recording, the slides, and also a quick survey for those of you who have tried either Engine or Lookout. We'd love to get feedback. So thanks a lot, and
thank you very much.
Good day, good night, good evening.